Okay, welcome to the code explanation for the traffic light state machine model. If you haven't checked out the hardware version of that, there's a video that you can check out for that, but this is the Arduino code explanation. So we're going to start with identifying which pins we're going to need. We have two sets of traffic lights, two green, two yellow, and two red lights. So we're going to use pins 8 through 13. 11 through 13 here will be for our first set of lights, and then 8, 9, 10 will be for the next set of lights. So when you do it with the hardware, make sure you follow the pins exactly. Next, we're going to set integer values for the pins for the two buttons that will control or influence the light sets. We'll call those button 1 and button 2. And here we're going to use an unsigned long data type for the green time and the yellow time. This allows us to hold quite a large number here, just good practice, but we're going to do it for 10 seconds and 1 second respectively for those two states. You can change that. We're going to need to keep track of at what time was the state last changed, and we're going to start with a 0 there. And then we're going to keep track of which of the 4 states we're in when we're using our switch case. We're also going to keep track of whether or not we think the button is pressed with a Boolean value. And those will start as not being pressed. Okay, so that was our initialization values. Those values have the scope that allow everything else to access them. Now we have a setup method that'll run once every time the program is executed on the board. And the first thing we're going to do is open up a serial monitor connection. And we want to do that because whenever we're doing a hardware project like this, that's DIY, experimental, and learning, we want to be able to have checkpoints in our code for the board to communicate to the Arduino IDE what is going on, so that we can understand and insert moments in time that we can check the actual state of something. Okay, so we'll first set the serial port as being open there, serial.begin, and then we'll set the 6 pins for our lights to be used as outputs. And then we'll set the 2 buttons to be used as inputs. Here we're enabling a resistor that will pull the value that we need to read the button when it is in its open state here. Okay, so the initialization of the lights will just give us a starting state. It's optional here, but it's just good practice. And then finally, we're going to set the last time we changed state at the beginning to whatever time in milliseconds have passed since the Arduino board has been turned on here. Importantly, we're not using the delay method to wait for a state change because we want the button press to intercept any of the states at any point in time. So we're not using any delay here, we're just keeping track of how long the board has been on, and we're setting that here with the millis function method. Okay, so that was the setup method. Now we're going to look at the loop that is run continuously throughout the life of the program. We're going to set the current time each time to a variable that we can access in the scope. We're going to check on the button state here, and for each frame of this loop method, we're going to grab that current time. We're going to see if we need to change the state of the button to see if it's been pressed. And we know if it's been pressed if that pin reads a low value. And then we're going to go into our switch case state, and we'll have 4 states here starting at 0. The first case being if the traffic is free for the north-south direction and stopped for the east-west direction. You can check out a diagram for the other 4 states, but they're basically opposite this, so red being stopped, north-south being red, and east-west being green, and then the 2 transition states between them. Here we're taking a moment to write to the serial port that we are in this state so that we can keep track of what state we're in at any given time. And we're going to check to see if the difference between the current time and the time we last changed is greater than the amount of time we should be in this state. So if that is greater than 10 seconds from the last time we changed the state, then we should be changing the state again, or if the button for this state has been pressed. So either the time transition or the button press will transition us to the north-south yellow state, and this is the state that is transitions to the red state, or the red case for north-south. So we're getting to a red light here, basically. So the digital write for these two is just to configure the green as being off and the yellow as being on. Not much else to change there. And then we're transitioning states, and that's what changing the state here does, because every time we get to this switch, we check for the state and we go to that state. So that's how we transition out of it. The last change is equal to the current time, so we're checking for that current time here and noting when we last changed the state so that we can compare the yellow time to it. And then we're resetting the flag for the button. So in each of these four states, case 0, 1, 2, and 3, we cover the case where the elapsed time has taken place, and there's no way via button presses or input sensors to get out of the yellow state. The yellow is set up to be a transition state to the red state for any given direction, and so we're not checking for a button there. And then we transition over to the next case. The north-south red, east-west green case is our opposite direction, so it looks much the same as the other green case, which is we're checking for time, the elapsed time since the last change, or the button press. And same, we transition back over to the yellow state. This final state here will transition back over to the beginning state. And actually, I just noted an error. There is no fourth state here, so this state should be 0. There we go. Okay, and so finally we're resetting the flags for our buttons, and that's it for our explanation.